and we have from Group 8. I'm Jovian, and this is Edmund, this is Yuseng, and this is Yuzeng. Today we're about to present our econometrics group assignment. And I'll pass to the introduction to Yuseng to further elaborate.
Hi everyone, my name is Yuseng. So now I will talk about the introduction. So my question is, what powers the Japanese economic growth? So Japan is a very well developed economy which has special economic trends. This presentation looks at the macroeconomic variables that influence the gross domestic product (GDP) of Japan, and develop an econometric model in the estimation of the impact of each variable on GDP. We will focus on 4 independent variables which are the foreign direct investment (FDI), gross capital formation (GCF), exports, and savings. And so what is the impact of FDI, GCF, exports, and savings on the GDP of Japan? We will look at the next slides. Okay, this slide is about theory and research questions. So the first question is, does FDI has technology, capital, and productivity and gains which imply that there will be a beneficial impact on GDP? The second question will be, the GCF indicates domestic investment thus likely to give a positive contribution. Next, the third question is, does exports earn national income sooner or later, a positive effect? And lastly, the fourth question will be, does increases in savings can increase investment, yet the excessive saving can decrease consumption that lead mixed level of effect? Yeah, that's all for my part. I will pass to Edmund to talk about the next slides. Thank you.
Thank you, Yuseng. My name is Edmund, and I will discuss about the model specification and variables. And this is our model, and in this model, GDP of Japan is our dependent variable, and foreign direct investment (FDI), gross capital formation, export of goods and service, and gross domestic saving as our independent variable. And let's look at the correlation table that we have run. This table shows the relationship between the dependent variable and our independent variables. Starting with the GDP, there is no relationship between the GDP and FDI, and we can observe positive moderate correlation between with both gross capital formation, export of goods and service with GDP, and gross domestic saving shows a weak positive correlation with GDP. And now let's look at the relationship among the independent variables. And for FDI and gross capital formation, there is a negative weak correlation, and there is a positive moderate relationship between the FDI and export of goods and service, and there is also a negative moderate correlation between the FDI and gross domestic saving. And moving on to the next is gross capital formation and export of goods and service. There is no correlation, and one of the important findings is we can see that there is the 0.915. There is a very strong positive correlation between the gross capital formation and gross domestic saving. And the last is export of goods and service and the gross domestic saving. It has a negative weak correlation on it. And moving to the next slide. This is the table that we have run on the multiple regression models. Here is the 10 models. As we can see that model 4 and model 6, both of the model, the variable are significant, and the adjusted R square is higher, the standard error of estimate is lower. we didn't choose model 8, 9 and 10 is because even they have a higher adjusted R square and lower standard error of estimate, but the significance, but 3 of these models, some of the variables are not significant. And this is our data source. This is the table of data analysis of correlation that we have run in Excel, and below is the link that where we get our data, which is in World Bank. Next. This is the graph of dependent variable, which is the GDP of Japan and in current US over 24 years from 1990 to 2023. And this graph, you can see the curve going up and down. The next, these are our independent variables. These are more details of graph for gross capital formation. We can see the graph is also moving up and down. And this is our export of goods and service, which is also moving up and down. And the last is gross domestic saving. This is the result that we have. This is the result of residue analysis for our best model. From this histogram, the dependent variables are normally distributed. Therefore, the residue are normally distributed. And this, the normality shows that the dots are generally lined up along the line. Therefore, the residue are normally distributed. The last is the scatterplot graph. You can see that there is no any patterns, so the residue have constant variance. And next, I will pass it to Jovian to talk about the key model result.
Hello, my name is Jovian, and I'm about to present the key model result for our group. And as you can see from model A, this is our model 4, if there's a confusion. And the R square is 0.742, the adjusted R square is 0.726, standard error of estimate is 3.39 E plus 11, and the p-value t-test and f-test is lower than 0.001, make it both significant. And moving on to the next, this is our model B. Model B, which is our model 6. As you can see, the R square is slightly higher of 0.746, and the adjusted R square is 0.729, and the standard error of estimate is lower in 3.317 E plus 11, and the p-value for t-test and f-test both are significant and lower than 0.001. And moving on to the next, as the pictures to show clearer to compare the both models. As you can see, model B, which is model 6, have a higher R square and a higher adjusted R square compared to model A, and standard error of estimate is also lower compared to model A for model B, and the p-value for both is significant, and therefore from these two strong models we have chosen up the best model, which is our model B. This model B had an R square of 0.746, and the coefficient of determination is 0.864, which indicates that the variation that explains GDP is 74.6% in the model. And as you can see, that the gross domestic saving and export of goods and service can explain the variation in GDP, which covers almost 75% of the variation in GDP. And the p-value both tests is significant also. The f-test and t-test both is lower than 0.01. And moving on to next, what is our issue with our regressions? We have two issues. The first issue is that, as you can see, why Edmund did not mention about FDI is because we have omitted FDI from our model due to its insignificant p-value, which falls on 0.73, which is very high. And as you can see from the correlation table, there is literally no relationship with GDP and for FDI. And so that's our first issue. On our second issue is that on this table we can see that GCF and savings have a high correlation of 0.915. And this indicates that there is a strong multicollinearity with both independent variables, and it will cause an unstable estimate and insignificant coefficient. And therefore, we have separated two models, model A and B, to run this issue, and we have chosen the best model as our model B. And I'll pass the conclusion to Zheng to wrap it up.
Thank you, Jovian. My name is Liu Zheng, and let me conclude our presentation on the econometric analysis of the Japan's GDP determinants. First of all, for our research, based on research, we have examined four key variables, which is our exports, investments, gross capital formation, and foreign direct investment, to evaluate the impact of Japan's GDP. After building and comparing multiple regression models, we found that exports of the goods and service and the gross capital formation are significant predictors of GDP. The model have these two variables, and have an R square of 0.742, indicating they explain 74.2% of GDP variation of GDP. Then another combination is the model with saving and exports, which provide the best explanatory power, which is our best model. It had the lowest standard error of estimate with an R square of 0.746. That means they are accounted for 74.6, almost nearly 75 of variation of GDP. In addition, residual analysis has also shown that they are normally distributed, indicating the model is statistically very reliable for inferences. On our research, we found that export consistently have a strong and significant positive influence on Japan's GDP. And when combined with the savings, they will improve the expenditure will improve covering that Japan's economic growth is largely driven by external trade and domestic financial capacity. That's the end of our presentation. Thank you for listening.
Before using edit, I have to add on my best model. And as the best model, we've constructed our model as we've constructed our model as constant model y equals to negative 4.544e plus 11 plus our export, our independent variable, which is 2.574, and plus another independent variable, which is our gross domestic saving, 2.689, and that's our final model. And thank you for listening.
Okay, thank you. Okay, good presentation. So your final model is model number 6, right?
Yes, model number 6.
Okay. Can you explain what is gross capital formation? What does that mean? What is gross capital formation?
It's investment.
Investment by? You have the 4 variables, right?
Yeah.
FDI, export of goods and services, gross domestic saving, and gross capital formation. What is that actually?
Gross capital formation, it represents like the total value of what the nation invests in fixed asset or like changes in inventories of Japan. The total investment.
How does it differ from gross domestic saving?
The gross domestic saving is the total nation savings.
Okay.
Yeah. It's one is investment and one is savings. Yeah.
on the potential issues with the regression,
Right.
can I see back, side, back, come on, go back, some more, okay, stop here, the next one. This one why you put under data sources?
But we need to change it on key model.
Because what Joven you are presenting is actually a repetition of what he has already presented. There's
Yeah.
overlapping, right?
Yeah, I need to.
This one you did not really, emphasize on this. Okay, normal distribution is fine. Can I see the next slide? So the title is not correct. Okay, this is fine. Hey, can I go before this slide? You see, when you say dependent variables are normally distributed, therefore the residues are normally distributed. How do you come up with this conclusion?
It's
Not necessarily when dependent variables are normally distributed, the residuals are normally, not necessarily. I highlighted this in your individual assignment, yet the same mistake. All your individual assignment, I already mentioned this. You go back and check your individual assignment.
okay. Sorry for this.
Next. Okay, next, okay, sorry. Next. Yeah, when you're talking about constant variance, now your model is to two variable, right?
Yeah.
Y, your GDP with another two variable. When you're talking about constant variance, how many total graphs do you need? Scatter plot, you need three, right? Y with the predicted value is here. You need, residue with predicted value is here. You also need residue with your the two independent variables. That graph is not here. So we are not sure whether the residue and this part is met or not. And how about your serial correlation? Did you test on that? Next slide. Where's your serial correlation? W Watson statistics. Where is it? You only tested two, right?
Yeah.
How about serial correlation? W Watson statistic is that out.
Oh, with GDP with these two very independent variables.
I don't you know what I am asking?
Yeah.
You missed out that the slide. Okay. Because all this part is repetition. Because I can see all this in the whole slide, which is very good. In the whole thing, right? I can see all this really. So there's no point for you to repeat on this because it's already been mentioned earlier. So you can actually emphasize on the model specification. But it's good you were talking about multiple linearity, where you remove your